Hi there, all you math wizards and witches. To see where we are? Well, that's right. We're going to be looking at multi-step equations and how to solve them. So we'll be looking at how the distributive property works with solving those equations, as well as combining like terms. It should be a fun time. Are you ready? Abracadabra! Is that a spell? I don't know. All right, let's get to the examples.
Okay, so solving multi-step equations. This is the bread and butter of algebra. And here we go. I'm going to talk about some general rules. And we're going to add on to these rules and maybe even modify some of them throughout the year. But right now I want to give a fairly good sense to you guys on strategies for solving equations. And I'm going to try and make it as easy as possible for all of you. Now, there are a couple of pre-rules. So the pre-rules are this. Number one, get rid of any fractions. Now, we're not going to dive into this today, although it is in the challenge section. But getting rid of fractions makes kids feel better. And the second thing is, I'm just going to add here, and this is a possibility to do. You don't need to do it, but you might want to distribute brackets first. So this is building on some things you learned probably already from your math teacher. So those are the first couple of rules to get you going before we dive into the real ones. So I'll put those in. I'll leave those in red, like that. And now we're going to get on to step-by-step of how to solve equations. So to do that, I'm going to start from scratch. And I'm going to give you an example. And we're going to work through that. Okay, so that's what we're going to do. So here's the example right now. So we're going to go 7x plus 2 is equal to, and we're going to say it's going to be equal to 5x plus 10. There we go. Okay, so what kind of rules do we need? Number one, you want to get rid of what I like to call the plain numbers on the left. So get rid of the plain numbers on the left. These are the constants. So these are things that are not variables. So if you look over here, what is the constant? What's the plain number? Is the positive 2. So just ask yourself, how do I get rid of positive 2? What's the opposite? I'm going to subtract 2. So you're going to subtract 2. And as you know, the golden rule, you must do the same thing to both sides. So now we have 7x is equal to 5x plus 8. And the second rule is get rid of variables on the right. So get rid of the variables on the right. Now, we'll get into this later, but basically you could switch these up a little bit if you wanted to. But most kids feel a lot better when the variables are on the left-hand side. And I want you guys to feel good. So now we're going to have 2x equals still 8. And this comes down to rule number 3. There's different ways to kind of go about it. But just realize the very last step, almost always when solving equations, is to multiply or divide. And I'm going to write that down. Multiply or divide by the coefficient on the left. These are some fancy words. So the coefficient is just that number that's in front of the x. So by the coefficient on the left side, I must write small and fit it in. There we go. So I'm going to go and divide both sides by 2. Now, you're like, well, how could you multiply? I'll show you in a second. So if I did all that, I get the answer now. X equals 4. There we go. So this multiplying or dividing, you can see that I went and divided there. I'll show you another way where you're going to be multiplying. It doesn't involve fractions. So let's take a look at one of those, what that might look like. Same sort of thing. And here we go. So let's say you had something that was like this. Let's say you had 3/4 plus 2, oh, sorry, 3/4 x. So 3/4 x, let's make it look nice. 3/4 x plus 2 equals 12. Okay. So 3/4 x plus 2 equals 12. So the first thing is that I got to get rid of all the plain numbers on the left. The plain number is a positive 2. So I'm going to subtract 2 there. And now I'm going to have 3/4 x equals 10. Now how do I get rid of the 3/4? Well, there's 2 ways, and this goes back to probably what you've learned about dividing fractions. If I divided both sides by 3/4, which I could do, so I could go and I could say I want to divide this by 3/4, and I want to divide this by 3/4. You could do that. But you know, if I divide anything by a fraction, you're really multiplying by the reciprocal. Okay, so that's kind of where I'm getting at with that last rule I just had you guys kind of look at. So let's get rid of this. And let's go back to what I would do if I was a math student and doing this question. I wouldn't divide by 3/4. I would multiply both sides by 4/3. That's what I would be doing. So I would be multiplying both sides. And put this over 1 so it looks better. So I'd multiply this out. Over here, what that does when you multiply by it, it eliminates, it cross-reduces all of those, leaving you just with x. And you get the fantastic answer, because you're going to multiply across the top and across the bottom, and we're going to have 40/3 as your final answer. Yay! And everybody's happy. Maybe he's kind of crazy. He's like, woo! And there we go. Give us some hair. So there we go. Let's get into two other questions, 2 more examples, and then we're done. And the examples are going to be just a couple of different things. So a couple of different things. And let me just grab a different color pen. Here we go. What happens if you have to distribute? So let's look at this one. 3 times x plus 2 is equal to 24. So for this one, you have to go and distribute first. This comes back to one of those like little pre-rules. So I would distribute first. And that means I would get 3x plus 6 is 24. And now I'm back to that same situation. Get rid of the constants on the left. And luckily, we will not have any variables on the right to get rid of. So I just have to go and somehow get rid of that 3. The very last step is almost always going to be like multiplying or dividing. So it's a good way to kind of think about it. If you're doing that at the very end, things are good. So that will eliminate my 3's. And I think we can do this one. And x will equal 6. Okay, and there we go. Let's take a look at one more. And this one is going to have some combining like terms. So this one is a good one to kind of look at. So let's say we had 7x plus 2x plus 4 is equal to 76. Okay, so one of those things is we want to always combine like terms on the same side if possible. So before I even started, I'd want to go and combine these because they're the exact same kind of terms. They have the same variable and the same exponents. So 7x's and 2x's, I have 9x's. And I still have my 4 and the 76. So I'm going to subtract 4 from both sides. And now what I'm going to have is 9x being equal to 72. How do I get rid of that? 9? I divide it by 9 and divide it by 9. So x will equal, let's see, I think that's going to be 8. Because those got eliminated. This becomes 8. So there we go. Some different examples of solving multi-step equations. We're going to keep building on this and take a look upcoming at the challenge stuff if you want to, because you might feel like, hey, I can do some challenge. And take a look at the next little clip as well. All right. Okay, so let's take a look at the very first example of multi-step equations. And we're going to start with a couple of things to be aware of. I'm going to put a negative sign outside this bracket. And that is going to have definitely some impact on everything. So this is negative times, in brackets, 2y plus 1 is equal to 8 times, in brackets, y plus 2. So we're going to work with some distributing with terms on both sides, some y's, and rearranging some things. So the very first thing, you have a negative sign outside a bracket, so we're going to have to go and distribute, and it's a negative 1 distributing against both things inside the brackets. And over here, we have an 8 distributing against the y and the positive 2. So what do you end up getting? You end up getting negative 2y minus 1 is equal to 8y plus 16. Awesome. Now, we need to get our constants on the right-hand side and our variables on the left-hand side. So I'm going to get rid of my negative 1 here by adding 1 to both sides. And I'm going to do what that looks like right now. So that leaves me with negative 2y is equal to 8y plus 17. Okay. Now, I need to get my y's on the left-hand side. So again, I'm going to go and I'm going to subtract 8y like this. And I'm going to subtract 8y or like that. And what does that leave me with? That's going to leave me with negative 10y is equal to 17. Boom, just like that. Now how do I get that y all by itself? I'm going to go and divide this side by negative 10 and this side by negative 10. Okay, so what that does, again, over here is going to eliminate our negative 10s, leaving me just with y. And then you get this. Now, can you do anything with that? No. So your final answer is y equals 17 over negative 10. Some kids ask me if that's the same thing as this. Y equals negative 17 over 10. Or is it the same thing as y equals negative 17 over 10? Those are all the exact same thing, just written a little bit differently. So there you go. Let's take a look at the next one. So this is going to be, I think, a fun question. And we're going to have to go back to probably grade 4. So we're going to go back in the time machine. We're going to go to grade 4. And we're going to remember about lowest common multiples and denominators and fractions. So here's the question. I want to get rid of my fractions. So how do you do it? Well, first off, I'm going to show you a little trick that I always do. I always put just plain old constants over 1. This makes everything look like it has a fraction. Ask yourself, of 1, 3, and 5, what's the lowest common multiple? Did you come up with 15? I hope so. So I'm going to multiply everything by 15. I'll show you how I do it. I draw it as a giant 15. And then, over in the top corner, I ask myself, 5 times what is 15? 3. 3 times what is 15? 5. And 1 times what is 15? 15. When you do all that, this will eliminate all of your denominators. Gone, gone, gone. And now what ends up happening is you end up getting these numbers multiplying against this stuff. Okay, so that's what's going to be happening here. The 5 is going to multiply by this stuff. And that 15, oh, that big number 15, is going to multiply by the 6. So what do we end up with? 6f plus 3 is equal to 20. Oh, sorry, it's not equal to. Oh, there's a plus sign there. So I can put that in brackets to make it kind of clear. Plus 20f plus 35 now is equal to 6 times 15, ouch, 90. Ooh, that hurt. Let's combine our like terms on this side. So we'll have 26f plus 38 equaling 90. Let's go and subtract both sides by 38. And what are we left with? We're left with a 26f is equal to, I'm running out of room. What do we got here? We got 52, I think, is equal to 52. Divide both sides by 26, and I believe f will equal, boom, 2. Woohoo! All right, so there you have it. Some more challenging questions for solving. I hope that gives you some tips and tricks.
Thank you for watching this video. I hope you guys learned some things. If you have any questions or comments, leave it down there. And if you have any suggestions on some new spells, let me know. Till next time.